Okay, so in this video we're going to try and rationalise denominators. When we're talking about a rational denominator, what we're talking about is the denominator, so bottom part of the fraction, without a surd sign. Remember that if we write a surd, then a lot of the time the square root of 5, that is an irrational number, meaning that it doesn't have any repeating parts, and it keeps on going on forever. Kind of like how pi is irrational. Okay, so to rationalise, basically we want to make it a whole number. So the easiest way of doing that is to multiply the bottom by itself. So multiply root 5 by root 5. But one of our golden rules with doing that to fractions is whatever you do to the bottom, you have to do to the top. So we're also going to multiply the top by the square root of 5. Now we can do that because square root of 5 over the square root of 5 is equal to 1. So effectively we're multiplying by 1. But what that does is it undoes the bottom. The square root of 5 multiplied by the square root of 5 is, well, do it the long way first. That's the square root of 25. The square root of 25 is 5. So what we get when we do that on the bottom is we have 5. As I said, whatever we do to the bottom, we have to do to the top. So we're going to get 3 root 5 on top. So that's now been written with a rational denominator. And just check that we can't simplify that. We can't, so that's how we leave that one. Let's move on to the next one. Same thing again, we've got root 15 on the bottom. We want to make that a rational number. Same thing, multiply both top and bottom by root 15. Now on the bottom, square root of 15 multiplied by the square root of 15 is 15. And on the top, the square root of 8 multiplied by the square root of 15, well, 8 times 15 is 120. Now, we need to look at that the surd that we have at the top there and just see if there's any way we can simplify that surd. Now remember, when we are trying to simplify surds, we're looking for a square number factor. So a square number that goes into 120. Well, let's look at our square numbers. I'm just writing them up the top here. And all I'm doing is writing out all the numbers, which, that's 2 squared, that's 3 squared, so on and so forth. Let's see, is there a square number factor? Well, there is. There's 4. Okay, so if we want to simplify that, we say, well, I'm going to show you over to the side here what we kind of think. We don't usually write it at this stage. 4 times by what gives 120? Well, it's 4 times 30 gives 120, and we're still over 15. So that's the equivalent of what we had there. Now what we can do is bring that square root of 4 outside, because we know the square root of 4. The square root of 4 is 2. So really what it becomes is 2 root 30 over 15. And that's how we simplify that. We can't simplify the 30 underneath the root sign anymore. There's no square number factors that go into it. So that's that one done. Okay, with our next one here, I might just move it down so we've got a little bit more room for number 3. Let's have a look. This time what we've got is we've got an expression underneath for our denominator. Now when we've got an expression like that, we can't just simply go and multiply by itself, because it won't necessarily give us just give us 15 on the bottom, or a rationalised denominator. So what we do is we multiply by the conjugate. Now, essentially what that means is, I hope we can remember our difference of perfect squares. If we remember this relationship here, that helps us to rationalise the denominator when we've got a plus or minus involved down the bottom here. So what we're going to multiply that whole expression by is by its conjugate. Square root of 10 minus 2 root 3. So when that's a plus there, we just write the same thing but with a minus. We're going to use this here to help us work it out. So remember that it is a times in there. We won't write the times, but we've got a binomial here. Now, same thing as what we did up here when we're timesing here. Whatever we do to the bottom, we've got to do to the top. So we're also going to times the top by that same thing. And remember brackets, because it's a binomial as well. It's actually an expression there that we're multiplying. Okay, so when we expand now, let's expand the top. We're going to get that's equal to 2 root 50, remembering that we're using FOIL now. So we've gone the first 2 here, then we're going the outer 2, so it's a positive and a negative give a negative. 2 times 2 gives 4, and then root 5 times by root 3 is root 15. Then we're going inner, a positive and a positive give a positive. 4 times root 10 it is, or 4 root 10. And then our last 2 terms are these 2 here. We're going positive and a negative give a negative. 4 times 2 is 8, and then root 3 on the end. So that's the top expanded. And on the bottom, now this is the reason that we multiplied by this, is now we're going to use that relationship there. We're going to say, well, it's root 10 times by root 10, which is 10. Then we're going to say, well, it's minus 2 root 3 squared. So minus 2 root 3 squared is 4 times by 3. Now, I'll just show you that over to the side here. That's what we get, 2 root 3. So when we do this, we go 2 squared, which is 4, and root 3 squared, which is 3. So it's 4 times 3, which is eventually 12. Okay. Now let's just tidy it up a little bit. Now, I'm just going to look at the top here. I'm just going to look underneath all these surd signs and see if I can simplify like I did over here. Is there any square number factor? First of all, it goes into 50. Well, yes, there is. 25 is a factor. So we make that 2 times by 2 root, where are we? Root 50, I'm just going to show you over the side here, is square root of 25 times by 2. Square root of 25 is 5, so it's 5 root 2. Now we're multiplying that by 2. So I might just show you the whole thing. That becomes 10, because 2 times 5, root 2. Then minus, 15 we can't do, so 4 root 15 plus still 4 root 10 and minus 8 root 3. Now all of that is going over. Now let's see, 10 minus 12 is negative 2. Now it says to leave it in simplest form. Now at the moment it's kind of correct, but we can simplify. And we should simplify by looking at the top, at the coefficients of all these. We kind of call it a coefficient because, you kind of treat this like they're like terms up the top, or like surds, or, there's no like surds that we can add together. So what I want to do is I'm going to take out negative 2 as a common factor for all of these in the numerator. And I'll show you why negative 2. We don't really like having that ugly negative underneath there. So we're going to go negative 2, bracket, negative 2 times by what will give 10 root 2? Well, it's negative 5 root 2. And then negative 2 times that, well, it's going to be positive, because we've already got the negative. Negative and a positive give the negative. 2 times 2, root 15. And then we want to get a positive here, so I'm going to get a negative there, because I'm timesing by 2. And it's going to have to be 2 root 10. And then here, we've already got a negative, so I'll make that a positive, and it's going to have to be 4 root 3. All of that over negative 2. And what that essentially does is it's going to get us to cancel the negative and cancel the 2's as well. Meaning that we can rewrite that whole thing on the numerator, and in fact the denominator is now gone. And instead of starting with that ugly negative, I'm going to start with a positive here. I'm going to go 2 root 15. I might change it to put that now 5 root 2 minus 2 root 10 and plus 4 root 3. Now, that's a correct answer. You can write those in a slightly different order, but that's basically what you'll get. Okay, let's look at this last one. Same thing, I'm going to multiply by the conjugate. Okay, so before we had a plus, this time we've got a negative, so we're going to go 2 root 7 plus, though, 4 root 2. Whatever you do to the bottom, you do to the top. So 2 root 7 plus 4 root 2. And again, use FOIL to start with here. So we go 5 times 2 is 10 root 21. Outer of those two. So 5 times 4, so positive first of all, and 5 times 4 is 20. Then underneath the root sign we've got root 6. Inner, so these two here, we've got a negative and a positive give a negative. 8 times 2 is 16. 16 root 7's on the end of that. And then our last two, negative times by a positive is a negative. 8 times 4 is 32. And then we've got root 2 on the end. All over. Now again, we're going to have, just sort of think about this, 2 root 7 getting squared will give 4 times by 7. The 2 gets squared, the root 7 gets squared, root 7 squared is 7, 2 squared is 4. So you've got 28 for that part there. And then it's going to be minus again, and we're going to have 4 times 4 is 16, and root 2 squared is 2, so 16 times 2. 16 times 2 is 32. Okay, so that's tidied up that little part. And remember, we're not using FOIL so much for this one. We notice this is a difference of 2 squares. This is an A, and I'll just do this in a different colour to show you. It's an A minus B, A plus B. Remember, that gives A squared plus B squared. That's the A squared part. The B squared part is the 4 root 2 all getting squared, which gives us 16 times by 2, which is our 32. So that's kind of where we're getting that. This is the A squared and the B squared. Okay, let's try and tidy up at the top here. Well, first of all, are there any like surds? Are there any surds that we can simplify? No square number factor for any of these. So the only thing I can do is I can take out a common factor. And the highest common factor for all of these coefficients is 2. So I'm going to take out 2 as a common factor. Bracket. Well, 2 times 5 root 21 gives 10 root 21. Plus 2 times 10 root 6. Then we're going to have minus 8 root 7. And minus again, this will be 16 root 2. All over. And on the bottom, we're going to have negative 4. Now let's just finish that off. Okay, so we can take out 2 as a common factor there. Now, really what you should do here is you don't like having that negative on the bottom. You can bring the negative up to the top here, and then really if you've got that negative up the top instead of down on the bottom, you can just simply go through and change all of the signs. So, you know, what I'm going to do is I'm just going to start off with one that's going to become positive, which will be 8 root 7. It was a negative, but because we've got a negative there already, it becomes positive. I might change that one to a positive as well, so plus 16 root 2. Then these both become negatives because they were positive, so minus 5 root 21, and then minus 10 root 6. That would be the simplest form of that.